Hello class, and welcome to Module 2. This week we're going to look at maps, lambdas, and RegEx. Before we go into some of the code here, let's just take a quick look on Blackboard so you can see what you're going to be looking at this week. You can see topic 1 is all about maps, topic 2 is about lambdas, and we'll also do a quick comparison of arrays and lists because I want to make sure that we remember the differences between these two for topics in the coming weeks. And then topic 3 is a regex primer. Now regexing is a very deep topic. We're just going to touch it lightly so you can be aware of it for any kind of use you run into. Regexing, unless it's something you do all the time, is something you kind of have to dig into for each unique scenario where you're attempting to use it. This week, remember that we also have our module help Q&A here. Please make sure that you go into this and that you subscribe. Remember, I will also be putting my slides or my notebook from this week in here, so you can pull down the notebook if you would like. And then also, before you leave the module at the end, make sure that you've completed all 3 assignments that are due in this module. Now over to look at some code. So topic 1, map functions. When you think of a map, this isn't the kind of map like a Cartesian coordinates map. This is a way to pass an iteratable, such as a list, a tuple, a set, into a function and get an output for each item in that iteratable. It can be used to do a lot of data passing through functions, and it can be done very quickly. So, just said that, I preempted myself. The output of a map function is a map object, which you would typically then convert back into whatever type of iteratable is most reasonable for your uses. So here's an example. First, I'm creating a function. You can see it's called doubles. All it does is take a number and multiply it times 2 and return the number. Then I'm also going to create a list called numbers to double, and I'm just going to put some numbers in there. And this is where I'm creating my map object. So you can see I'm using map, and I'm telling the map what function I want to use, and then I'm telling it what list I want to pass into the function. And then I'm assigning that to a variable called result, and that result, when it runs, will become a map object. So to see the output, I'm going to take my result, I'm going to convert it into a list, and then print it. So if I run this now, you can see the end result is that all those numbers in the list are doubled. I will show you what happens if I don't put the word, or I don't cast it as a list here. All you get is one of those ugly objects at memory location. So it's not super useful, which is why it's good to just convert it into an iteratable so you can see your result. So what I just did, we've done before using for loops. Not a very difficult thing to do with a for loop. You just step through the list, and then you call the function for each item in the list, and then you concatenate it back into a list and output it. Not too difficult to do. However, the difference here is we can do this quicker using map functions. So one of the nice things about Jupyter Notebooks is that it has a it has a lot of built-in stuff. One of the built-in things it can do is a timing tool that can time how long it takes for code to execute. And the way this works is it times running through the cell 1,000,000 times and determining the average time it takes to run. So I'll just show you here. If we did this with a for loop, which you can see here, it's going to go through. When there's a star here, that means it's still executing. It takes a little bit to do something 1,000,000 times. You can see that it took 981 nanoseconds. Now I'm going to do it with mapping. It only takes 175 nanoseconds. Now these are both very quick timings, but if you were to try to do something in a large data set, which we'll be getting into later in the semester, this can mean the difference between something taking minutes to run and hours to run. So it's something you want to be aware of. Here I'm going to show you another example where we're going to use object-oriented programming and pull attributes from our objects very quickly. So here's a class I'm creating. It's just called class person. It's got a few attributes, age, gender, hair color, and then I'm going to instantiate 4 objects, Jim, Jane, Tim, and Tina, and they just all have different attributes. And then I'm going to create a list of those people. So this is a list of objects for Jim, Jane, Tim, and Tina. There we go. I've created my list. And now I'm going to use a lambda. Now I'm going to show you lambdas here in the next section here, but I wanted to show how I can map this information using the next slide here. So I'm going to create a variable called ageList. It's going to be a map of the age attribute of the people in this list. And then I'm going to print it. And you can see it pulls 25, 30, 35, and 40, one for each person in the list. That's why it's pulling the age of the variable. Now I'm going to do some timing on that. I'm going to, again, create an empty list, and then I'm going to assign that empty list with the list information by doing exactly what I did in the previous slide. I'm not going to print it here because I'm doing timing on it, and that would affect the timing. I want to run this. You can see it's running here because of the star. And when it completes, it gives me my timing. I can do the same thing, just like before. I can do the same thing using a for loop, doing the exact same thing, creating an empty list. And then for each item in people list, I'm going to pull the age and append it to this list. So I will end up with the same result. I'm just using a for loop instead of a map. And this one will take a little bit because what we're doing here takes. This shows that actually in some cases mapping is not faster. When you do a map like this where you require the use of Lambda, you can find that a for loop actually will run more efficiently for your code. So the thing to remember is that it depends. Sometimes just creating these little snippets of code and testing, just like I have here, will give you an idea of what typically will run faster or slower. You can also use multiple iterables. So that just means that you have multiple things that the function calls, and each one of the things the function calls can be pulled from one of those iterables or mapped from one of those iterables. So let's do this. I've got a function here that calls number 1, number 2, and number 3, and then adds them up and assigns them to final number, and then returns final number. Pretty simple function. And now I've got a list of numbers, a tuple of numbers, and another list of numbers. And you can see here I have a note here that this one's intentionally shorter. And then I'm creating a variable called output list. I'm going to map list 1, list 2, and list 3. I'm going to map to my function, list 1, tuple 2, tuple 1, and list 2, etc. All three of my iterables. And then it's going to be a mapping, and then I'm going to convert that map to a list, and then I'm going to print that list. So the reason I shortened this one is to point this out. The mapping will only map to the length of the shortest iterable that is an input. So I don't know if that's going to be useful, but it's just something to be aware of. So in this case, my shortest iterable is this list. It has 5 items, and then the mapping ultimately results in only a list of 5 items long. And it's just 2 plus 2 plus 4 equals 8, 5 plus 5 plus 7 equals 17, etc., etc. It always starts from the left, works its way across. Okay, that's everything I want to show for mapping. Mapping is a good thing just to be aware of. There are cases where it can be useful. There are other cases where it may just create complication. It's very important to remember these type of tools when we get into those larger data sets later. Now, Lambda functions. Lambda functions are another thing that does have its place. Part of the reason I'm showing you this is because as you look at code online, you will run across Lambda functions because it's clever. Sometimes people just like them because they look clean. A Lambda function is also called an anonymous function, and they essentially are limited versions of simple functions written in a kind of a shorthand format. They can really only have one statement, and they just automatically return the result. So I'm just going to show you a couple of examples. So here I've got a function. This is the traditional way, or the longhand way, I guess you could call it. Again, adding 3 numbers up, 3 inputs from the user, returning those 3 inputs, and then I call the function for 5, 6, and 7. So then 5 plus 6 plus 7 equals 18. Here I'm doing the same thing, except I'm using a lambda. So here's the variable I'm creating, and then I'm utilizing lambda, telling it what the 3 inputs are, and telling it what the 3 inputs are going to do. and then the Lambda will automatically return the result, and then these are the 3 inputs. So I'm doing everything all in one line. It's kind of a one-use throwaway thing. So I don't have a name for this function. I can't call this function again later. It's just created on the fly, anonymously, and does what it does, and then you can continue with your program. So you can see the result is the same. It's just all done in a condensed way right within the code line. You can also do your Lambda function a little bit differently. You can create the variable that is assigned a Lambda function, and then you can call that variable with inputs. This is kind of a little wonky because you're essentially to the point where you're creating a function here, so you may as well just create a full function, but this is something you can do, and this is something you may run across as you're doing research on coding and such. As I said, in most cases, these functions aren't necessary, and you can replace them in other methods. Just want you to be aware, because you'll see them occasionally while looking at code online. Okay, regexing. Regexing can be fun, and it can be infuriating, because sometimes just getting things just right can be difficult. It is a structured way to search and edit data. We really could spend weeks on just this one topic. Regexing isn't just a Python thing. Regexing is a language in and of itself. It's used in different places, just again to search through data in a structured manner. I want you to understand it enough that you can see how it works, and then just get a little bit of practice, because there may come a point later in the semester or in your career or whatever, or you're using a completely different tool where you may find that regexing can be quite useful. First thing you have to do to do regexing is you do need to include the re library, and then let's do a little bit of work with it. So first you need to import re. I believe it comes with the standard Python installation, so all you have to do is just import it into your program. And I'm going to mess with this search string I've created. You never really understand a person until you consider things from his point of view. And then I'm going to create a variable called x and do re.search, so it's a regex search method. And then I'm going to search for the string u, and then what I'm going to search is the search string. Note, doing it this way will only return the first result. So if u appears here multiple times in this string, it will take the first one and return that information for you. And I'm just going to run this so you can see it. You can see it found a match this first time. It found it in the 0 through the third character. Remember, it's always exclusive on the endpoint, so it's characters 0, 1, and 2, and then the match equals u. And then here I'm doing another search for the word understand, and doing the same thing. So it found a match between characters 17 and 26. So that'd be the 18th character. Remember, we're 0 indexed, so the 18th character through the 25th character is understand. And then this third time I search for the word whatever, which does not appear anywhere in the string, so I just get a return of none. So just a good way to search things. Here I'm going to use some regex characters. Now that's just seeing the regex library do something. This is actually using some regex code to find all the letters lowercase t in that same string and return it and the 3 characters after it. So I'm going to, that's that search string from previous, and I am going to find all, which means it doesn't just find the first time in it, it's going to find every instance of it. And I'm doing this regex string that essentially says, find me anything that has the letter T, and then return it and the next 3 characters after that. And then I'll print the result. And you can see it turns it into a list, and it gives me all the returns. So I found a T, it gave me A and D, found a T, gave me IL space, the word thin, which had more characters after that, and then here it was at the end of a word, and it found a space and of. So I found everything in that string that matched that and gave me back my result I requested. Those ones with the space in it I didn't really care for, so I'm going to adjust my regex search to only return if there are 3 actual characters after the letter T. So if it finds a space in the result, it's not going to return it. So here, instead of using 3 dots, which is it stands for essentially anything, I'm using 3 escape characters. \s means give me it only if it matches a character. So again, find all, T, some character, not a space, some character, not a space, some character, not a space. And again, it's searching that same string from before, and then I'm going to print the result. So this time, I only get 2 of the 4 because there's no spaces in the return string. We could take a long string of text and split it up into individual words. That can be really useful if you're doing, like you're downloading a book and you want to just turn it into a big list of words that you can analyze. You can do it very quickly this way. Here's the string. I'm going to use a dot split, and I'm going to split it on \s, which \s means space. And then, so anywhere it finds a space, it's going to split it into an individual, at that point, into 2 different values. And I'm using that same search string, and then you're going to see the result here. Instead of getting 1 big string of text, I'm getting a series of items in a list. And all of them are broken on that space between the words. So that can be pretty useful. Now, I'm going to just remove some text from my original string. Because I don't want them there. I don't know why, but I just don't want them there. And I'm going to do u, a, and of, and then I'm going to assign the string to a new variable so I don't mess up the original one I was working from. So I'm creating a variable called updated search string and doing re.sub. And what I'm saying here is find u, and these spaces are important. So I'm saying find the word u with spaces around it. So all of this is actually the search. U space, or, that's what the bar character means, or space a space, or space of space. If it finds any of those 3 things, it's going to replace that string with a space. Okay? So if it finds space, u space, it's just going to become a space. So essentially I'm taking a word and removing all of the stuff it is and around it, and then just putting a space in its place, essentially getting rid of the word. And then, again, that same original search string, and then I'm putting this flag in here to ignore case, because otherwise, if it was a capital U instead of lowercase u, it wouldn't find it. And then I'm going to print a new string. So you can see u, this u was kept here because there wasn't a space in front of it. U never really understand person, so I got rid of A, until I got rid of this U, consider things from his point of view. And there was A here. You never really understand a person. So if let me just do this so you can see the difference. Print search string. There you go. So now you can see the difference here. It dropped the A, it dropped the U, and it dropped of here. So I was able to get rid of those words in my string and then create a new string. This could be useful if you are doing something, again, like a text analysis, and words u, a, of, those common words don't really bring any value in determining, let's say you're trying to determine what the sentence is about or what the string is about. So you dump those things because they're just not valuable. And then you could break this up into individual fields if you wanted to, or something like that for your analysis. Okay, that's the last thing I have here for RegEx. So this is, again, a very simple intro. You get to push it a little bit further in the assignments, so you can try a little bit of different stuff. There's a lot of resource about RegEx online, especially the RegEx strings. You don't necessarily have to limit those searches to Python. RegEx itself, again, as I said, is a language unto itself. So you can utilize those things to try to get these search structures that you need correct. Again, as always, this notebook will be available for you to download in Blackboard in the help section, as well as on my GitHub repo, and I make myself available, as always, to assist if you have any questions.